To continue with our polynomials, we're going to do another example and see one more detail that we have to look at, and that's called multiplicity. So here's our example. G of x is equal to x minus 4 squared times x minus 8 times 2x plus 1. Okay? So this is the given problem, and we're going to find out a lot of information from it, and we're also going to graph this polynomial. Okay, so first of all, I want you to notice that this is already factored, right? This is in factored form. So that's good. We don't have to factor it ourselves. We really don't need standard form, and so it's better if it's in factored form. All right, so first of all, we have to figure out the degree. So the degree of the function, remember, you really need the first term of standard form, right? So in other words, the degree is what would be if it was all multiplied out. Okay, so we would multiply x, and this would be x squared, right? Because it would be x minus 4 times x minus 4, so that would be a quadratic x squared. So that's 2 x's. Here's one more x here for the x minus 8. And then this is 2x, so that's one more x, right? So in other words, in standard form, because we do kind of need this whole leading term, the first term is 2x to the 4th, right? The 2, because of here, there's no other coefficients. And then there's 4 x's, so the degree is 4. So this is going to be an even degree function, right? All right, so the zeros, there could be up to 4 zeros, okay? So first 0 is our, so in other words, we're setting the entire function equal to 0, okay? So in this case, we have x minus 4 squared equals 0, okay? It doesn't really matter. We could just unsquare it by taking the square root of both sides. So then we're just left with x minus 4 equals 0, and we get x is equal to 4. Okay. This one we have x minus 8 equals 0, so that's x equals 8. And this one we have 2x plus 1 equals 0, so x equals negative 1/2. Okay, so we have 3 zeros right there. Remember, we could have up to 4 zeros, but this one, because of the squared here, this one's kind of like happening twice. Okay. We also want to find out what the leading coefficient is. But good thing, we already did the work on that. The leading coefficient is right here, 2, and it is positive. Okay. For graphing purposes, we're also going to want the y-intercept. We already have the zeros, which are the x-intercepts. The y-intercept is, of course, where x equals 0. We have to use factored form. We have no choice. So this is the g of 0. So that's 0 minus 4 squared times 0 minus 8 times 2 times 0 plus 1. Okay, you really got to do the work on this one. So that is, I'm seeing 16 times negative 8 times 1, right? Which I don't know what that is off the top of my head, so let's see if I can't find my calculator. Okay, so that is equal to negative 128. So the y-intercept is negative 128. Okay, so we also want to talk about the end behavior. And that's like as x is going towards infinity, what is the y doing? Okay, so remember that we want to look at the degree for that, and we want to see whether the leading coefficient is positive or negative. So if we have an even degree, then the ends need to point in the same direction, up here or down here. So when the leading coefficient is positive, they go up. So that means that y will go towards infinity. And even as x goes to negative infinity, y will still be going to infinity. Okay, let's graph this and see what we need to do about having only 3 zeros for this degree 4 polynomial. Okay, so first of all, we have those 3 zeros. Let's graph those first. 4, 8, and negative 1/2. Okay, we also can graph our y-intercept of negative 128. There it is, perfect. And then we also want to graph that end behavior. So we know that the graph at the ends, after our zeros, is going to go up and up, okay? Now, the graph can only pass through this point here and these 3 points on the axes. It cannot go through anywhere else on those points, okay? So we can probably see that it goes through here, and then it goes all the way down here, and then it starts coming back up, touching here, right? So what's happening at x equals 4, though, is a little bit special, okay? Because it's x minus 4 squared. Think about what a quadratic looks like, right? Think about what a parabola looks like, here or here. At this 0, this turns and goes down again. Okay? And that's because of the multiplicity of that 0. So x minus 4 squared has what's called an even multiplicity, okay? And it's the x minus 4 squared term that's causing it not to just pass through, but to turn and go back down. All right, now when it goes over here, it just goes right through there. So what we want to start noticing then is in the factored form, we can see what's called multiplicity. How many times does the 0 happen? So this 0 happens twice, so it's going to look like a quadratic. This 0 at 8 happens once, so it's going to look linear. It's just going to pass right through. And then this 0, 2x plus 1, negative 1/2 being the 0, also you just pass right through. That one looks a little messy on my graph, but you still get the idea. It just goes right through, okay? And that squared is called even multiplicity. Okay, now to finish this problem out, let's use limit notation to describe the ends of the graph. So over here, we have the limit of g of x. Oops, I'm not going to have room to write the answer. Let's see if I can scoot this over a little farther. Somewhere else, somewhere else. Okay, let's do it up here. Limit of g of x as x approaches infinity is equal to infinity, right? It's going up there. And over here we have the limit of g of x as x approaches negative infinity, and that is also infinity. Okay.